Hello, algebra students. Today we're going to be covering the Unit 7 activity. And so go ahead and open up to that if you haven't already. Should look like this. Let me share my screen. Okay. So it should look like this. This is what the introduction looks like on page 3. And go ahead and read this silently as I read aloud. It says, recall how we can use quadratic equations to model real-world situations. For example, we can use a quadratic equation to model the path of a ball tossed into the air through time, the number of boat rentals over time, or in business to describe profit as price varies. In fact, we can use a quadratic model anytime we want to model a situation that steadily increases, peaks, and then steadily decreases, or a situation that steadily decreases, reaches a low point, and then steadily increases. In this activity, you will use quadratic equations to interpret and model situations and make predictions based on your models. Now on page 5 says, in this activity, you will use factoring and graphing to solve real-world problems. You will also describe transformations to the graph of y equals x squared. Okay, question 1. Jen and her friends are designing a robot for a STEM competition. The goal of this competition is to have a robot complete an obstacle course in the least amount of time. Jen and her friends need to consider the robot's height and its width at its base. The robot must be short enough and narrow enough to navigate through several arches along the obstacle course. The director of the competition laid out components of the obstacle course on the coordinate plane. Instead of giving the width and maximum height of the arch, the director created an expression based on the location of the arch on the coordinate plane and gave each team this expression to represent the height of the arch in inches at any value x along the arch. So here's the equation, and this equation models the arch that the robot needs to go under or whatever. Okay. So the first question says, factor the expression and use the factors to find the x-intercepts of the quadratic relationship it represents. Type the correct answers in each box, starting with the intercept with the lower value. Okay, so our equation was negative x squared plus 5x plus 24. And remember, our goal for the first question is to factor this thing. So we want to factor it and then show what its x-intercepts are. So let's go ahead and factor it. Now, when I see a negative in front of the x squared, I want to factor that out first. So I'm going to divide everything by -1, essentially changing the sign of every term. So when I see a negative in front of the x squared, I generally don't like that, so I factor that out. So this negative x squared becomes positive x squared. The plus 5x becomes minus 5x. And the 24 becomes minus 24. Now, when we factor it, if you recall, we use this big X, and the constant term goes on top, and the middle term goes on bottom. So I'm looking for two numbers that multiply to give me -24, but they add up to give me -5. So two things that multiply to give me -24 and add up to give me 5. Now, I know one of these is going to be positive and one of them is going to be negative. And the way I know that is that they need to multiply to give me a negative. So they have to be different signs. So the different signs multiply to give me a negative. So pause the video, see if you can figure out what two numbers multiply to give me -24, but add up to give me -5. Okay, hopefully you got -8 and +3. They multiply to give you -24, and they add up to give you -5. So that means our factors, this negative sticks around, but our factors are going to be x minus 8 times x plus 3. All right, so this is the factors. Now, in order to find the x-intercepts, what you do is you set each of these equal to 0. So first, let's do x minus 8 equals 0. And you'll do the same with this one. So x plus 3 equals 0. Okay, I'm going to go ahead and solve this one here. So in order to solve it, to get x by itself, I need to subtract 3 from both sides of the equation. This will give me that x equals -3. Go ahead and do the same thing here. Solve for x and figure out what the x-intercept is. So this tells us our x-intercept is -3, 0. Do the same thing here. Figure out what this other x-intercept is. So our first x-intercept was -3, and then hopefully you can figure out what the second one is. I'm going to leave that to you. Okay. So what you should have gotten in the last problem is that one x-intercept is -3, and the other one, if you haven't figured it out yet, it's +8. Okay, so these are our x-intercepts. Now, let's figure out the y-intercept, because in this question, it says draw a diagram of the archway modeled by the equation, same equation. Find and label the y-intercept, the x-intercepts on the sketch. Find and label the width of the archway at its base and the height of the archway at its highest point, assuming the base of the archway is along the x-axis. So you can imagine the archway goes through these 2 points. So it kind of goes up like this and back down. It's going to look something like that. And what we have found so far are the x-intercepts. We found those in the last problem. Now we need to find the y-intercept. Now the way we find the y-intercept is we take this same thing and we replace the x with 0. So anytime you want to find the y-intercept, you just replace the x's with 0. So in this equation, if we ever replace the x's with 0, it's going to be -0 squared plus 5 times, again replacing the x with 0, plus 24. So I just replace the x's with the 0. You can see if I replace the x's with 0, this goes away, this goes away. So the y-intercept is 24. And we'll call it 0, 24. Y-intercepts are always 0, something. So this is our y-intercept. We'll go ahead and graph it, 0, 24. So now we can get a better idea of what the arch looks like. But we still need to find the highest point. Now when they say what is the highest point, that's the same as asking what is the vertex. So the way we can find the vertex is we can do this little formula called, and it's basically -b divided by 2a. And I'll show you how to use this formula. Now the a and the b come from this. The a is whatever's in front of the x squared. So you can see there's like a negative in front of the x squared. So we consider the a as -1. So in this case, our a is -1. It's like -1 x squared, basically. The b is what's in front of the x. So in our case, the b is 5. And the c is whatever the constant term is. In this case, 24. Now, we don't need c in this formula, but this is going to come in handy later, actually in the next unit. So knowing how to find a, b, and c from a quadratic equation is very important. It's going to come in very much in handy. So in our case, we're going to do -b. So in our case, 5 is b, so that's going to be -5, replacing b with what b is, divided by 2 times a. A is -1. So that's going to be -5 over -2, which divides a negative divided by negative is positive. 5 divided by 2 is 2.5. So what does this tell us? This tells us the x-coordinate of the vertex. The x-coordinate of the vertex. In other words, the x-coordinate of the highest point. To find the y-coordinate, we're going to plug this back into the equation. So I'm going to replace the x's with 2.5. It's going to be -x squared becomes -2.5 squared. plus 5 times x becomes 5 times 2.5 plus 24. That doesn't change because there's no x attached to it. Okay, so now just use a calculator, and we're going to calculate what this is. So 2.5 squared, and so that's 6.25, and this negative makes it negative 6.25. Remember, the negative does not get squared here, so whatever answer here stays negative. Plus 5 times 2.5, 12.5, plus 24. So let's add those together. So we got 6.25, negative 6.25, plus 12.5, plus 24. So 30.25. Now what does this tell us? This tells us the y-coordinate of the vertex. So now we can graph it on our thing. It's the x-coordinate is 2.5 and the y-coordinate is 30.25. So 2.5 is like here, and you go up 30.25. So 30, just barely above 30, let's say. Right there. All right. So now we can really see what the arch looks like. Go ahead and use this tool right here. We can click, try to draw as smooth as curve as possible where this is the highest point, and then come back down to this other x-intercept like that. Okay, not bad. Not the best work, but pretty good. Okay, so now we want to, like it says, label some stuff. So to get to label on this, go ahead and click on this T right here. This will pull up a text box. And one of the things it asked us to label was the width. So the width down here, the distance between the x-intercepts, you can see that distance is 11. From -3 to 8, that's a distance of 11. So you can go ahead and click, and we put the width, and put 11. We also want to label the vertex, it said. So we'll put the vertex, which is the highest point. And that was 2.5, comma, 30.25. Just like that. Okay. I want you to also label each of the x-intercepts and the y-intercept. So finish that labeling for the x-intercepts and the y-intercept. All right. Now, let's talk about how to move a graph of x squared. So here's a graph of x squared. We're going to talk about how to move it. So if I want to move it up, well, what do you suppose I should do here? Well, if I add something to the end of this, not in the parentheses, but outside the parentheses, not getting squared. So if I add something to that, let's say 4, notice that moves my graph up 4. So before it was down here, but when I do that plus 4, it's the same graph, just moved up 4, shifted up 4. Similarly, if I replace that plus, let's say instead of a plus 4, I did a -4, it would shift it down 4. So on the outside here, it shifts our graph up or down depending. So it shifts up if it's a plus, down if it's a minus. Now what about in the parentheses? Like what would happen if I put a +4 in the parentheses? Would that move it up like how the +4 outside did? Well, no. A +4 in the parentheses actually moves it to the left 4. Kind of counterintuitive, right? You would think to the right if it's a plus. But it actually moves to the left 4 when you do a +4. What do you suppose is going to happen if I put a -4? Well, it's going to move it to the right, just like that. I hope that kind of makes sense. From here, what we're going to do is drag these to the correct answers. So in this one, x squared -2, that's going to shift the graph down 2. So I'm going to shift down to, like that. Drag and drop the rest of these into the correct spots. And let's go on the next one. So go ahead and pause the video and go ahead and finish that. And then I'll move, we'll be talking about the next one. Now we're going to talk about how to make the graph skinnier or wider. So if I put a number out in front here that's greater than 1, so any number that's greater than 1, we put it here, let's say 3. Notice it makes it skinnier, right? And the bigger the number, the more skinny it makes it. So if I change that 3 into a 30, much skinnier. Or how about a 300? Oh, much skinnier, right? So any number out there that's greater than 1 will make the graph skinnier. If I put that number inside the parentheses, let's see what happens. Oh, it makes it skinnier as well. 30, wow. 300, wow. So very, very skinny there, right? Notice that in the parentheses, it makes it skinnier even more than outside. The reason why is because that number gets squared. So when I put a 3 here, I'm actually doing 9 because that 3 squared gives you 9. Notice putting a 3 in here is the same as putting a 9 out here. Same exact graph. Okay. So any number attached to this that's greater than 1 will make the graph skinnier. Now, what if we put a number that's less than 1? Let's say 0.4. Oh, notice it made it wider. Okay, wider. So any number attached to this that's less than 1 will make the graph wider. What about in the parentheses? Ooh, even wider still. Again, because it gets squared. So any number attached to it that's less than 1 will make it wider. Any number attached to it that's greater than 1 will make it skinnier. Now, what about if I put a negative out in front of this? Will that make it skinnier or wider, or neither? Well, if I put a negative, let's see what happens. Oh, well, it actually makes the graph go downward, you see. So having a negative out in front like this doesn't make it skinny or wide on its own. It just makes it shift downward. Or not shift, but flip downward. If it's positive, be going upward. Cool. So when you look at this, which ones make it steeper? In other words, skinnier. Well, any of them that have a x attached to the x greater than 1. What about less steep? Well, any of them that have attached to it something less than 1. So I want you to put the rest of these into this, and one of these is not going to be used. So you'll have to figure that out. But put the rest of these correctly into steeper or less steep. In other words, skinnier or wider. Again, one of these is not going to be used. Once you're done with that, join me on the next page. Okay. In this activity, you'll create quadratic inequalities in one of the variables and use them to solve problems. Read the scenario and then use the information to answer the questions that follow. Noah manages a buffet at a local restaurant. He charges $10 for the buffet. On average, 16 customers choose the buffet as their meal every hour. After surveying several customers, Noah has determined that for every $1 increase in the cost of the buffet, the average number of customers who select the buffet decrease by 2 per hour. In other words, if he increases the price by $1, there'll be 2 fewer people that choose the buffet. That makes sense, right? If you increase the price, fewer people are going to choose that option. The restaurant owner wants the buffet to maintain a minimum revenue of $130 per hour. Noah wants to model the situation with an inequality and use the model to help him make the best pricing decisions. Okay, so write two expressions for this situation, one representing the cost per customer and the other representing the average number of customers. Assume that X represents the number of $1 increases in the cost of the buffet. So for the cost equation, well, the original cost was 10. Look at this, charges 10 for the buffet. But he wants to know, we're going to increase it by X dollars. So X is the amount of dollar increases. So if we only increase it by $1, increase the price by $1, then the total cost would be $11. Now the number of customers, our starting number of customers was 16. But the number of customers that come to the buffet goes down by 2 for every dollar. Okay, so if I increase the price to $11, right, X would be 1 in this case, increase the cost to $11, then there would actually only be 14 customers because 2 times 1 is 2, and then 16 minus 2 is 14. Right? I hope that makes sense. If I increase the cost to $2, that'd be 10 plus 2, that's $12 cost total. And the number of customers that choose that would be 16 minus 2 times 2. So in other words, 16 minus 4, which would be 12 customers. Okay. Now, if we recall up here, it says the restaurant owner wants the buffet to maintain a minimum revenue of $130 per hour. So when I look at our inequality, this will be the revenue coming in, and we want the revenue coming in to be greater than or equal to 130. The revenue coming in needs to be greater than or equal to 130. Let's figure out this revenue equation by multiplying these two together, because the cost times the number of customers will give us how much money they're bringing in. So the cost was 10 plus X. And the number of customers coming in is 16 minus 2X. Now, how do we multiply those together? Hopefully you remember, like foiling, right? So 10 times 16 and 10 times negative 2X. So the 10 multiplies with both the terms over here. So that's 160, 10 times 16, 160, minus 20X. Because the 10 times negative 2X. Now we multiply the X times both of these terms in the other. So X times 16 is plus 16X. Okay. Just want to make sure I was still presenting. Yeah. And then X times negative 2X is negative 2X squared. Okay. So now we want to combine like terms. I'm going to go ahead and put the negative 2X and 2X squared in front. And then it's going to be minus 4X, combining these, plus 160. Just like that. So that's going to be here, negative 2X squared plus, what was it, negative 4, I believe. Yeah, negative 4X. Plus 160. This is the amount of money coming in for each increase in X, and we want that to be greater than or equal to $130 of revenue. So, which possible buffet prices could Noah charge? I'm guessing that's a typo, and still maintain the restaurant owner's revenue requirements. Select the correct answer prices in the table. So we want to see which of these prices, if any, will be acceptable. So we have this inequality that this needs to be greater than or equal to 130. Now let's go ahead and try putting in a $12 price. So if we do a $12 price, X will equal 2. Well, why not 12? Well, remember, X is the amount of increase in price. So the original price was $10, and we'll be increasing the price by 2 to make a $12 price. So in this inequality, I'm replacing the x's with 2. And I want to see, is this going to be greater than or equal to 130? Let's see. So replace the x with 2 here and with 2 here. So that'll be negative 2. X squared will be 2 squared. Minus 4 times x becomes 4 times 2 plus 160. And I want to know, is that greater than or equal to 130? Well, we'll see. So here we'll do 2 squared, that's 4. 4 times negative 2 is negative 8. Now remember, you do the exponent first, then multiply. Then 4 times 2 is negative 8 plus 160. Go ahead and combine these together, and that'll give you 144. And indeed, that is greater or equal to 130. Okay, so as you can see here, it's definitely greater than or equal to 130. So we're going to go ahead and click 12 as an acceptable price. Go ahead and check 13. So 13 is the same deal. You just go back to this and replace the x's with 3 this time. So it'll be negative 2 times 3 squared. Again, replacing the x with 3 minus 4 times 3 plus 160. And I want you to work that out and see if this is going to be greater than or equal to 130. If it is greater than 130, then go ahead and click that. If it's not, then don't. Then check 14, replacing all the x's with 4, and check 15, replacing all the x's with 5. So you're going to check each of these prices. Now in part D, assuming that any increase occurs in whole dollar amounts, what is the maximum possible increase that maintains the desired minimum revenue? Explain why this is true. So we already discovered that 12 works, but is that the greatest amount? Well, you'll have to check these other values to see. If 13 ends up being the greatest amount, if 13 ends up working and the others don't, then you'd say 13 is the greatest price that it could have. If 14 works, then you'd say 14 is the greatest price that it could have. 15 works, say it's 15. Okay, so basically the highest value that works will go here. If none of these, if 13, 14, and 15 all don't work, well, we know 12 does. So you'd say 12 is the greatest dollar amount. But if 13 works, you'd say 13. Okay, so whichever value is the highest, but also gives you something greater than or equal to 130, that's the one you want to go with, and explain that there. Okay, so that's that. I hope that all made sense. If it didn't, well, you could always email me, and I can go over this with you, no problem. My email again is ttrigg@ofy.org. All right, again, that's ttrigg@ofy.org. All right, well, with that being said, hopefully you can turn it in, get a good grade. All right, hopefully that made sense. All right.